everybody. In this video, we're going to be deepening our understanding of probability. So take 3 deep breaths and let's make this math easy. All right, so in our last video, we talked about the basics of probability, which is when you're finding the probability of any desired outcome, you look for the number of desired outcomes and divide by the number of possible outcomes. So we did the example where if you were trying to find the probability of rolling an even number when you roll a standard 6-sided dice, you would say, well, I have 6 options or possible outcomes, and 3 of them are favorable because there's 3 odd numbers on a 6-sided dice. And you can represent that as a decimal by dividing 3 by 6, or you can also represent it as a percentage. So that's what we talked about in our last video. And if we think about it, all probabilities are going to have to fit somewhere between 0 and 1, because if you're trying to find the number of favorable outcomes out of the number of possible outcomes, well, the lowest number that you could possibly get would be 0. Like, for example, if you roll the dice, so we have 6 possible outcomes, and I asked you to find the probability of rolling, say, like a 10 on a dice. Well, there are no 10s on a 6-sided dice, and so that would be 0 out of 6, but there's no way that you could get a probability that's smaller than 0, because there's no way that you could get a negative number of favorable outcomes. So 0 is the smallest number that a probability can be. And it basically means that it's impossible for that thing to happen. Like, it's impossible to roll a 10 on a dice. And the largest number that a probability can be is 1. Because if you think about having something be the most likely, well, let's use the example of rolling a dice again. If I have 6 possible outcomes, and then let's say I asked you to find the probability of rolling a number that was less than 9. Well, all of the numbers on the dice are less than 9, and so you would have 6 favorable outcomes out of 6, which equals 1. But there's no way that you could get more favorable outcomes than the number of possible outcomes. So like, it's impossible for this number to be like a 7, because you can't have 7 favorable outcomes if you only have 6 possible outcomes. So all probabilities will always be between 0 and 1. And if you write them as percentages, that's the same thing as saying it's between 0% and 100%. And so if you ever get a probability that's bigger than 1 or bigger than 100%, then you might want to go back and check your work again. Because it's actually impossible for the probability to be more than 100%. And this leads to the formula that we have when we're trying to find the probability of something not happening. So whenever we're looking for the probability of something not happening, you basically just take 100% or the number 1 and subtract the probability of the thing happening. So for example, if we wanted to find the probability of rolling a number on a dice that is not a 2, one way you could do it is you could say, well, there's 6 possible outcomes, and the numbers that are not a 2 are the 1, the 3, the 4, the 5, and the 6. And so there's 5 possible outcomes that are not 2, and so the probability is 5/6, and you could change it into a decimal or percentage or whatever you wanted to do there. So that's one way you can calculate it. But another way you can also think about it is you can say, well, the probability of rolling something that's not a 2 is going to equal 100%, or the number 1, minus the probability of rolling a 2. And the probability of rolling a 2 is 1 out of 6. And if you do 1 minus 1/6, you have to get common denominators, so that'd be 6 over 6 minus 1 over 6. But you can see that you end up with the same answer of 5/6 when you solve it this way. So you can solve the not problems either way, but it is helpful to know that you can think about it this way. So why don't you try this one on your own? Look at this one and figure out the probability of randomly drawing a card from a standard card deck and having that card not be a face card. So pause this video and then restart it to see how I would solve it. All right, so on this one, the way that I would solve it is I would say, okay, well, the probability of not drawing a face card is 1 minus the probability of drawing a face card. So the probability of drawing a face card is going to be 12 out of 52 because there are 12 face cards. And if I do 1 minus 12 over 52, I can rewrite this as 52 over 52, so I have common denominators to subtract my fractions. And when I do 52 minus 12, this gives me 40 out of 52, which will be the probability of not drawing a face card. Now, you could have also got this same 40 out of 52 answer by counting up the fact that there's 40 non-face cards. So on your lesson, you really can solve them either way, but I wanted to introduce this to you because it's going to be useful later on in our unit when we do more complicated probability. So that's how you would do that example. And you can also do this with percentages. So this is a similar example to what we did in the last video. So we have a math class where 30% of the students earned an A, 40% earned a B, 20% earned a C, 8% earned a D, and 2% earned an F. If we randomly selected a student from the class and we wanted to find the probability that you select a student who didn't fail the class, this would be the same answer as what we found in the last video when we were trying to find the probability that you select a student who passed the class, because finding a student who didn't fail the class versus someone who passed the class is the same thing. But you could calculate it a different way than how we did it last time, because you could say the probability of not failing would be 1 minus the probability of failing. And so you could say, okay, well, what's the probability of failing? Well, there were 8% of the students who earned a D. Those students failed, and so did the 2% of the students who earned an F. And so the probability of failing would be 10 out of 100 because there's 10% out of 100%. So we could do this as 1 minus 10 out of 100. And if you write that out, that would be 100 over 100 minus 10 over 100, and that would equal 90 over 100, which gives us that same answer that we got in the last video. So again, you can solve these multiple ways, but this is a helpful way of thinking about it. Also, one thing I forgot to mention earlier is when you're subtracting this, you don't necessarily have to do this common denominator thing if you have a calculator, because you could just do 10 divided by 100 and find out what that decimal is, and then do 1 minus the decimal. And that would give you the exact same answer. So you don't necessarily have to do common denominators if you prefer not to work with fractions. So I hope this video was helpful, and I hope that you guys have a good day.